Hey, welcome back. So in this video, I'm just going to walk through the tests that I wrote to test the deck and card classes. They're actually the same tests that I wrote in the exercise when, I don't know if you did this, but if you did, enter your code into the Udemy Coding Challenge, Interactive Python Editor, Trademark, Copyright, all that craziness. I wrote these tests to go in there to test your code. Now I'm just going to walk through what they actually look like. So if we go over to tests, we can start with the card tests. So I import both things up top, and then I have my card tests class. There's no, you don't have to do a separate class to test cards and decks, or card and deck, but it's better to separate things. We could do all of this. I mean, you could technically write all of your tests in a single function or single method. It would just be kind of a nightmare to understand what was going wrong. So it's better to break things up. So with card, the first thing I have is a setup. I'm using the same card for all these tests, where I just have, initialize a new card with hearts. So suit is hearts and value is A for ace. Then to test init, I'm just using this self.card and checking that self.card.suit has been assigned to hearts and that self.card.value has been assigned to A. So to assert equals, and then our doc string. To test the representation, what's supposed to happen is that it returns a string A of hearts if we're using self.card. So I'm doing that. So we just do self.assert equal representation self.card. So this is the better way of testing it. You could also do self.card.repr and directly call the method, or we can use this function that will then call .dunder repr behind the scenes. Anyway, so we're testing that it's equal to this. So both of those work. Then we move on to the deck tests, the bulk of the logic. And I have the same thing where I make a new deck, self.deck equals deck. You don't pass anything in. So before every one of these, this code runs. First, I'm testing init, and I'm checking that assert true that self.deck.cards is a list, is instance list, should return true. And on top of that, we're checking that it has 52 things in it. I didn't actually check to see if the items were exactly cards. I just checked if there's 52 things in there and that it's a list. But then later on, I'm checking, certain things have to be cards. Anyway, then we have test repr. It's the same idea, representation, except I'm expecting it to say deck of 52 cards or deck of however many cards. But when we make a new deck, which is what happens, it should be 52. To test count, I'm first asserting equal that at the beginning, count is 52. Self.deck.count of a brand new deck from here should have 52 cards. Then I am popping one off, self.deck.cards.pop, and then I'm checking that the count has now gone down to 1, or gone down by 1. And that works as well. I should stop saying that. All of these work. I've already run them. You've seen me run them. There are 3 tests for deal. This method here, not deal hand or deal card, but just underscore deal, the method we use internally in those other methods. And there's 3 things I'm testing for. What happens if you ask for a reasonable amount of cards, that you ask for 2 cards and there's 50 in the deck, that's fine. But if you ask for 55 cards when there's only 52, what happens? And also if you ask for 2 cards when there's 2 cards left, does it still work? So back in the tests, the first one is just to check if there are enough cards left, it should deal appropriately. So we have a brand new deck with 52 cards. Then I'm calling .deal underscore deal with 10. And that should leave me with 42 cards. And what I do is check that when we call self.deck.underscore deal 10, I save the list to a variable called cards. And I check that there are 10 things in that list. And I'm checking that the count of self.deck has gone down by 10. So 2 things at once. If I was only checking to see if count went down by 10, then I might be missing the fact that those cards are returned. And there could be a problem where those cards weren't returned, they were removed and then never returned, which case this would not have full test coverage of this method. Then I'm doing the same thing, but trying to deal 100 cards, and that should never work because there's only 52 cards maximum. Same thing, so I call self.deck.underscore deal 100, save the result to cards, and I should check that the length of cards is all the cards possible, 52, and that self.deck.count is empty. And then lastly, this is a trickier one. Deal should throw a value error if the deck is empty and you try and deal from there. And if I try that, self.deck._deal, and I try to use the self.deck.count, which will then deal everything in the deck, this will empty it, drain it completely right here. Then I'm going to try and deal one more, but assert that it raises a value error, which it indeed does right there. Okay, so that's the syntax as we saw in a couple videos ago to test for errors. We use a with statement. Next up, we have deal card and deal hand. I'm checking that when I call deal card singular, it gives me the last card. And one way to do that is to start, have a brand new deck, which is from our setup all the way up here. And then I call self.deck.cards -1. So I'm not removing it. I'm just saving a variable called card equal to the last card in that list, but I'm leaving it in the list. Then I make another variable called dealt card, and that's equal to the result of deal card on self.deck. So that gives me the card, and they're supposed to equal one another. I was starting by checking what the last card was, and then I asked for the last card, and they should be the same thing. So then I can do a self.assert equal card and dealt card. They should be the same. And at the same time, I assert equal that self.deck.count went down by 1 and is now 51 cards. With deal hand, I'm dealing 20 cards at once, and saving it to a variable called cards. And then I'm checking that the length of the cards is 20. And then I'm also checking that the deck.count, the method, that's the number that's returned, has gone down by 20, leaving me with 32 cards. Almost there. Then we get to shuffle. As I mentioned in the intro, shuffle is harder to test when you have random stuff going on. You can't predict what it should equal exactly. So the approach that I took is a bit different. I made a variable called cards and set it equal to self.deck.cards, the slice with just a single colon, and that's just going to give us everything. It makes a copy. So I cloned it into a variable called cards. And I'm going to use that to compare after I shuffle. So I have the initial state. And the reason I have to do this, I couldn't just say cards equals self.deck.cards because it would be pointing to the exact same thing. And once I changed, self.deck.cards, cards would change as well. I need a copy of it. So that's one way of doing it. So I'm keeping the original state, and then I shuffle self.deck.cards. And then I'm checking that the two things are different now. Self.assert not equal. Cards is not equal to self.deck.cards. The initial state is different than the current state. And that's kind of all I could do. If I wanted, you definitely could be a lot more intense about how you check for the shuffle. But what I'm doing is just checking that they're different. So the before and after state are different, but that length is the same as before. Otherwise, if I had tried to shuffle, we could have just deleted everything from the deck. And if I didn't have this line, this test, all this would pass because we're just checking if the two things are different, before and after. And an empty deck is different than a full deck. But by doing this, I'm ensuring that it's still full at the end, but also different. And then we have shuffle on a non-full deck, an empty deck or a partially empty deck. The goal is to only be able to shuffle a full deck. So we just deal one card right off the bat, and then we call self.deck.shuffle, and we assert that that raises a value error. And it does indeed. So that concludes the little walkthrough here. Let's just run those tests. Without the -v, 12 tests run, everything's good. With the -v, we get all of this information, and everything's working. All right, so whether you actually wrote all of the tests and went along with this, or you wrote a couple of them and then gave up, or you rolled your eyes at me and just didn't do any of the tests, and maybe you watched this solution video, hopefully by now at the end of this section, you can see that testing is potentially useful. It also is potentially time-consuming, and it can be a lot of work. My goal with this section was not to try and convert you to a testing maniac or to a preacher about the benefits of TDD nonstop. I really just wanted to expose you to testing so that if you do keep working with Python, there will be a time at some point where you either have to write tests for your own project, for an open source project, you have to make sure tests are running correctly before you can submit a pull request, or you're working on a dev team somewhere, freelance or full-time, doesn't matter. You'll probably have to write tests, or at the very least, run tests to make sure you didn't break anything by adding changes in. So it's a good skill to have. Keep it in your tool belt, however you feel about it. Anyway, moving on to more fun stuff.